So here's our equation. Sulfite reacts with, and then this ion, this IO3 minus, it's called iodate. So when I refer to it as we're working this out as iodate, that's what I'm talking about, this thing right there. And those react and they produce sulfate and elemental iodine. So the first step in working one of these out is that you split the reaction in half. So if you split the reaction in half, we're going to break that into the iodate, IO3 minus, reacting to form elemental iodine. And then the other one is going to be the sulfite, reacting to form sulfate. So that's the first step. You break them into half. Now that they're broken in half, since it's happening in an acidic solution, you have waters and you have hydrogen ions, and they're going to be transferring electrons. So we also have electrons. What you don't have in the solution are any extra iodines or any extra sulfurs. And so if those are not balanced, you have to take care of that the old-fashioned way by putting a number out front. So if we look at the sulfite-sulfate reaction, you got one sulfur, so that's already balanced. But here you have iodate only has the one iodine, and elemental iodine is I2. So we're going to need to balance that by putting a 2 out front there. So 2 of the iodates will react and form 1 of the elemental iodines. Now step 1 was breaking it in half. Step 2 is balancing anything that's not hydrogen or oxygen or charge. And so then that gets us to step 3. You are going to try and fix the oxygens. So if I look at this guy, 2 sets of iodate gives us 6 oxygens total. So we're going to come over here and we're going to add, you'd have to add 6 waters to balance out those oxygens. Come over here, you got 3 oxygens on the reactant, you got 4 oxygens on the product. So we're going to add just an extra water, and that'll give us 4 oxygens on each side. Now in fixing the oxygens, we made ourselves a little hydrogen problem. So we need to now fix the hydrogens. This reaction is going to pick up 2 H plus ions, and notice they are hydrogen ions, so they are not diatomic, they are charged, they have a positive 1 charge, and so it's going to be 2 H plus. Over here we have 6 waters, so 6 waters gives you a total of 12 hydrogens. There are currently no hydrogens on the reactant side, so we're going to add 12 hydrogen ions. And now the hydrogens are balanced. The next thing we need to look at are charge, or is charge. So we are going to, let's start with this guy. So right now, this whole side, you got neutral water, and you have 2 minus on the sulfite. So this charge side has a 2 minus charge. You got sulfate and 2 hydrogen ions, so that's positive 1, minus 2. So this side is currently neutral. So you can add electrons, and so I'm going to add the electrons to the side with the higher charge. And 0 is higher than -2. It's greater than -2. So we're going to add 2 electrons to the product side over here. So we add 2 electrons, and now both sides will have a charge of -2. We come over to the iodine reaction, and we have, this side right now, neutral and neutral, so you got a 0 charge there, and then you have 12 of the hydrogen ions, so that's positive 12, and 2 of the iodates, so that's -2. So positive 12 minus 2, that gives you this whole side is positive 10. And since the other side was neutral, that means I'm going to need to add 10 electrons to the reactant side there. Now that's a good thing, because in these reactions, the electrons have to cancel out. And so we have 2 electrons here as a product. We have 10 electrons here as a reactant. And so if you're ever working one of these out and you get electrons for both products or electrons for both reactants, then you need to stop what you're doing because you did something wrong. So we're in a good spot. We got electrons in the iodine reaction as reactants. We got electrons in the product on the sulfur side, but you have very different numbers. You have 10 on this reaction and you have 2 on this reaction, and ultimately the number of electrons have to cancel. So what we're going to do is we're going to take this whole equation and multiply the whole thing by 5. And so if we multiply that whole thing by 5, so we'll distribute that 5 out, we end up with 5 waters reacting with 5 sulfites. That produces 5 sulfates, 10 hydrogen ions, and 10 electrons. All right. Now we get to the part where we can recombine the 2 half reactions. So we can take all of these reactants, combine it with all of these reactants, and we can take all of these products and combine it with all of these products. And so we get, and in that process, electrons will cancel. So that was our ultimate goal, was to get electrons to cancel. And so our final equation is going to look like 12 H plus ions plus 2 iodate ions plus 5 waters plus 5 sulfites react to form I2 plus 6 waters plus 5 sulfates plus 10 hydrogen ions. The only other thing that we can do here, we can eliminate some stuff, right? Because there are 5 waters on the reactants, there's 6 waters on the product. So that means 5 waters didn't really do anything. So we can get rid of 5 waters on each side. So that knocks that down to no waters. And this one's going to get knocked down to just 1 water. Blankety, blank, blink. All right, and then hydrogen ions. You got 10 hydrogen ions on the products. You got 12 hydrogen ions on the reactants. So we can get rid of 10 hydrogen ions on each side. So that knocks us down to 2 over here on the reactant side. All right, now you can check to see if you did this correctly. The way you can do that, so you're going to look at it in terms of charge, and you're going to look at it in terms of atoms. So is the charge balanced? Is the charge the same on both sides? So you've got, let's see, you got 2 hydrogen ions, so that's positive 2. You got 2 iodates, that's minus 2. You got 5 sulfites, so that's 5, 2 minus, so that's minus 10. So this whole side, those two cancel each other out. So this side is minus 10. You've got iodine and water, they're both neutral. And then you got 5 sulfates, 5, 2 minus, so that's minus 10. So both sides are minus 10. Charge is balanced. And then let's count it up in terms of atoms. You've got 2 iodines, 2 iodines. You got 2 hydrogens. You got 2 hydrogens there in your water. You got 5 sulfurs, 5 sulfurs. And then oxygen's the last thing. You got 5 sets of 4 and an extra one, so that's 21 oxygens on the product side. You got 5 sets of 3, that's 15. And then you got 2 sets of 3, so that's 6. So 6 and 15, that adds up to be 21 oxygen. So atoms also check out. So you got charge balanced, you got atoms balanced. So this would be the correct equation for an acidic reaction. And then take a look at a basic one.